Just got a little video this afternoon. Some components that have been sent in to us by a customer. We've got a late model Honda Civic ignition lock here. The customer's got the car from auction and he's got no keys for it. So what we've said to the customer is, if you take the ignition lock off and you send us the whole thing, including this module here, because this is where the immobiliser data is contained on these. If you send us this, and along with that, which is the driver's door lock, what we can do is we can create a blank key, which we have here. We can create this key and we can send this in. We can code this key into this module, decode these locks, and send the customer back a key that's ready to start the car. We've also we could also send the customer a remote key, if I can get it off here. We could also send the customer a remote key, but the customer isn't really fussed about that at the moment, and this would need the remote on this would need programming in manually anyway, so we're not going to bother with that at the moment. What the customer does want is he just wants a key that he can open the doors with, start the car, make sure the car runs, and then sort it out from there. So this video is about that. We're just going to show you the process on how we do that. So what we would need to do first of all is we're going to take this driver's door lock here, and we're going to use a special automotive pick and decoder on it, and we're just going to simply pick this lock to the open position, and then we'll read the code directly from the grid on the tool. And then once we've got this code, we can take that to our key cutting machine and simply just cut the key. It'll just take a matter of a few minutes. So with these locks, they've actually got split wafers in them, which basically means you have to pick the lock twice. So first of all, you pick it to 45 degrees, and then you need to pick it a couple of the wafers just a little bit further, and that will allow the lock to fully turn. But also, you also need to pick the lock back as well, which can be rather annoying. So we'll just get this picked quickly and then we can decode it. Just trying to make sure everyone can see this. So we've got a little bit of movement there. So as I say, that is now picked 45 degrees. So we've just got to pick another couple of the wafers, and we can get it a full turn. It's usually only one or two wafers that are holding us up. So we're okay there. Just the same process, we just go through it looking for the binder, which is that one, and that's it. That's the lock now fully turned. Now all we're going to do is try and get the glare off the light. This might be a little bit hard to see, but what we're just going to do is just go through and decode it. We've got 3, 4, 3, we've got a 3 and a 6 and A, That's a 4. It's a little bit difficult. We've got to put a bit of glare off this light for you to see exactly what we're reading. But basically, this indicates to us the cut depths on the wafers. And then, now I've got those cut depths, what you'll see is if I release the tool, it's gone back to the 45 degree. So I just need to just pick again just a couple of the wafers just to release it back to the vertical position. Because right now, if we put this back in the car, the lock would be at a sort of diagonal position, and the customer would be unable to get the key into it. One just dropped back. And there we go. So there, as you can see, that is back at the horizontal position. So what I'll do is we'll just pause the video, we'll go out to our machine and we'll put our cuts in, and then we'll get this key cut and see if it works. Right, so we're just at the machine now, and as you can see, that's our key cuts that we've entered into the machine that we got from our decoding tool. And we've got the key loaded in the machine there. So what we'll do is we'll just go ahead and cut that and see how it works out. It's just giving us some information about what the machine wants to do. So that's basically one side of the key finished. What we've got to do now is remove this key from our machine. Let's just give it a bit of clean up. So remove the key and then flip it over, cut the second side. So just bear with me while I get this key swapped over, as I need both hands to do that, and we'll be right back. Right, so we just got this key swapped over now, so we'll just close our shield, go back to our display, click OK, just go through the warnings, yes. And that's it, that's our key cut. So let's just get that out. And that's what our key looks like. And then if we try that in our door lock, as you can see, that is 100% perfect. A little bit difficult to do it with one hand, but as you can see, that turns 100%, no problems whatsoever. Absolutely smooth as silk in the lock. What we'll do is we'll just go back to the workshop, and we're going to put a chip in this key, and where that little red tab is that's sticking up, we'll pull that out. It's a little chip tray. We'll put a chip in this, and then we'll get this written into that ignition lock. So we're just back in the workshop now. This is our ignition lock that we was just looking at a minute ago. This is our key that we've just cut, and we can show you that goes in, turns, no problems whatsoever. This ignition lock only has 2 positions, but because I'm sure you're all aware, Honda Civics, they have a bit of an odd system because they have an ignition key, but there's no start from the key. It's a push to start ignition. It has a starter button, but it still has a key, which is really bizarre. But as you can see, that key that we've just cut is 100%. It goes in, no dragging whatsoever, absolutely smooth as butter. The problem with these Honda keys is the wafers inside these locks are so fragile. You get people, once the key gets a little bit worn or it has a little bit of a burr on it, something like that, they'll put the key in and they'll get it jammed, and then what they try and do is they try and force the key into the lock, and at that point all you are doing is damaging the lock. You're not going to get the key to work. If you try and insert your key and it doesn't move in and out freely, just get straight in touch with an automotive locksmith, because what I've seen people doing, I've seen people with pliers on the key, and I just think, oh my god, you've just completely destroyed that lock. And then we're going to come along, we're going to charge you quite a few £100 to replace that lock, or to take it apart and replace the wafers in it. The other thing is, if you end up going to a dealership, what they're going to do is they're going to supply you with a brand new ignition lock out of stock, and that will come with 2 brand new keys. They won't be matched to your existing key, so what you'll end up with basically a set of keys like that. One will be for your car, probably with the remote on it, and the second key will just be a generic basic key like that, which will be for the ignition. So, but we can rekey the lock so that it works from your original key. So what we need to do now is we need to add a chip to this key, and what we're going to do is we're going to, first of all, we're going to read the immobiliser data with our VVDI vprog, and once we've got that file saved on our computer, what we're going to do is we're going to use our VVDI2 to write the chip in. So let's just pop you up here, see if we can get have a look at this. So inside here, this module here, this is where our EEPROM is going to be. That holds the data for the immobiliser. So our target device is going to be this chip here. This is our target device. This is our EEPROM memory that contains all of our key data. So what we're going to do is we're going to get our VVDI we're going to get a special adapter that goes on there. It's our EEPROM clip reader. We're not going to bother removing this chip, we're just going to read it in circuit, see how we go on with that. Should be a piece of cake. So what we're going to do is, let me just put it back there for a minute. So this is our settings here. It's an ST EEPROM. It's a 24C04. So what we're going to do is we're going to try and read this. I'm going to try and keep my finger on it. Because it doesn't want to sit on there too well. We'll get that on there. Okay, so that there is the file that's stored on that EEPROM memory. So we can release that now. So this here is all the data that is stored in that chip. That is basically all of our immobiliser data, all of our keys, however many keys are in this memory are on there. Doesn't seem to be much data there, but what I have done, if you look down the bottom here, is what we do is we verify the chip read. So we read the data and then we verify it as well to make sure that what we've read is on that EEPROM and it is correct. So what we're going to do is we're just going to save this. We're going to call it Honda Civic Ridge. That's our original file, and we save that on our desktop. So if we just minimise that, and if we get our VVDI up, just takes a second to load. If we change this to Honda Civic, load dump, and there we have it. There's our two keys. That's the two keys that were originally stored in this device. So all we're simply going to do now is we're going to add a new chip, and we'll just prepare that now and then we'll get that added.